So now we'll move on to the next property, is related to the quotient rule. Okay, so this is the quotient rule. And in exponents, you saw the quotient rule like this. You saw b to the m over b to the n, and that was equal to, do you remember? That was equal to the m minus n, right? Okay, well, in logarithms, the equation is similar, kind of, again, like the other one was kind of similar, this one's kind of similar. It is log base b of m over n is equal to log base b of m. Now see if you can guess what the rest of this is going to look like. So over here, when we had something divided by something, we subtract the exponents. So here, when we have two things divided by each other, what do you think we're going to do to these over here? What do you think? We're going to subtract them, like that. So we're actually, again, able to draw a pretty similar comparison between what we did with the exponents and what we're doing with the logs. So the quotient rule is that if you divide two things within a log, that you can subtract them off like that. So, you know, you could have something like log base 7 of 19 over x. Maybe you decide to simplify that. You could say log base 7 of 19 minus log base 7 of x, like that. So you can actually use this to do, again, all sorts of simplification. So say we had that, remember what that was? Natural log, right? Natural log e cubed over 7. So we could rewrite this as natural log of e cubed minus, looks kind of funny, let's go away, minus natural log of 7. Now we can simplify this, right? Because this is like this one. It's like this one. No. Yes. But it's log base e. So that actually simplifies to 3 minus natural log of 7. So, you know, you've gotten rid of some of the ugly letters, so that's always a good sign. So you can do all sorts of stuff like this. Now, something we can also do is actually work backwards. So you can take something that has subtraction and rewrite it as a division, which is really kind of neat. So, for example, we might say log base 2 of 24 minus log base 2 of 3. And, you know, you can't solve this by hand particularly, or really at all. And remember what we say when we say log base 2 of 24. What we're really saying is 2 to the what is 24. So last time we were solving this, we were kind of like, not cheating, but we were writing a little x out there and we'd say, okay, 2 to the what is 24. And we'd say, well, I don't know, and then we'd kind of quit. We don't have to quit now because we're actually going to know a way around it, but I guess something I'm trying to get at is that when you're looking at a log, you don't actually have to go all the way here and write this out. You could just say 2 to the what is 24. So if I had log base 3 of 9, for example, you might say 3 to the what is 9. So again, if you put the x in there, 3 to the what is 9. You could say, oh, 3 squared is 9. Oh, okay, I get it. So rather than going through all that process, you can say 3 to the what is 9, 3 to the 2 is 9. So that's kind of a faster way to do logs. So let's say log base 4 of, 16. So 4 to the what is 16. And you would say, oh, 2. Or log base 2 of, non-2 number. How about log base 2 of 8? So 2 to the what is 8. 2 to the what is 8. 2 to the 3 is 8. So you can write those a little bit faster and not have to actually go write everything out. But we can't actually do that here because we don't know 2 to the what is 24, so we can't actually work that out by hand. But what we can do is we can apply our subtraction rule backwards. So we have m minus n. So we have log of m minus log of n equals log of m over n. So log base 2 of 24 minus log base 2 of 3 is the same thing as log base 2 of 24 over 3, or log base 2 of 8. And now we can come along and say, okay, 2 to the what is 8? We already did that one actually. 2 to the 3 is 8. So now we've taken a problem that we didn't know how to solve, and we couldn't solve by hand before, and now we're actually able to solve it and get an exact answer. So before we forget, let's make sure we go stick this over in our master list of properties. So we've got log base b of m over n is equal to log base b of m minus log base b of n. And since I'm being a good student right now, I'm going to go ahead and label this product rule, and I'll name this one quotient rule, because it's kind of nice to be able to refer to them by names, at least when you're learning them.